So for part two of our parent graphs, we're going to talk about the last three parents, 2 to the x, log base 10x, and 1 over x. These are a little different from the first four for a couple different reasons, mostly because you've not ever seen anything like them before and there's some new vocabulary attached. What I will suggest is that you make a table of values at first, follow along with me, and just do your best to get the idea of the shape of the graph, and we'll talk more about it as we go through the unit. Again, just keep in mind math is consistent, and what we do to a parabola in terms of transformations is the same as what we'll do to any of these other kind of stranger looking things. Make sure you write down your definitions and get a good table of values, and we'll talk more about these tomorrow. So here we have f of x equals 2 to the x. So what I would do is think about numbers. 2 to the 0, say. We've been starting with 0 when we've been talking about any of our parents. Well, any number to the 0 power is 1. And if you forget that, you can just grab your Inspire and look at a scratch pad. So I'm going to plot the point 0, 1. Let's think about 2 to the first. 2 to the first is 2. So when x is 1, y is 2. Plot that point. 2 squared is 4. So when x is 2, y is 4. 4. And 2 cubed is 8. So when x is 3, y is 8. So we have to wonder what's happening in the negative direction. Well, if x is negative 1, 2 to the negative 1, hopefully you remember from other classes that a negative exponent means a fraction or a reciprocal. So this is the same as 1 over 2 to the first, or 1/2. So when x is negative 1, y is 1/2. And we guesstimate 1/2. We go halfway between 0 and 1. It's not an exact point. 2 to the negative 2 then would be 1 over 2 squared, or 1 over 4. When x is negative 2, y is 1 over 4. So we can plot that. And what happens is this curve gets super close to the x-axis but never approaches it. We call that line an asymptote. An asymptote is a line that a graph approaches but never touches. It's not always the x-axis. We're going to see many different asymptotes as we go through the year and as you go through different math classes. But in this case, this graph of 2 to the x, this exponential curve, approaches the x-axis, y equals 0, but never ever ever gets there. You can't raise a number to an exponent and get 0 or a negative number. Again, for now, you just really need to know the shape of that parent to be able to plug in some numbers so that we can do transformations to it later on. And again, know your definition of an asymptote for pop quizzes. Okay, I want to skip 6 for now and go down to number 7. We're going to need our Inspire a little bit more for 6. So number 7 is f of x equals 1 over x. We call this the reciprocal function. And it's just what it sounds like. It's a reciprocal. So we've been plugging in 0 to start. So if x is 0, maybe we make a table of values. 1 over x is 1 over 0. Well, that's undefined. There's no such number. We can never divide by 0. So again, we're going to start dealing with some asymptotes. Can't plot 0 anything with a reciprocal function. Let's go to 1. If x is 1, 1 over 1, the reciprocal of 1 is 1. So we can plot that point 1, 1. If x is 2, well, the reciprocal of 2, 1 over 2, is just 1/2. So 2 1/2. And you keep thinking reciprocals. If x is 3, y is 1/3. If x is 1/2, the reciprocal of 1/2, or 1 divided by 1/2, is 2. So if x is 1/2, y is 2. And you can start to see this curve in quadrant 1. We've kind of hurt negative feelings, so let's think about some negative numbers. If x is negative 1, well, 1 over negative 1, the reciprocal of negative 1 is negative 1. Negative 1, negative 1 is a point on your graph. If x is negative 2, 1 over negative 2 is negative 1/2. So when x is -2, y is -1/2. We can plug in negative fractions. If x is -1/2, the reciprocal of -1/2 is -2. 1 divided by -1/2 is -2. So I can plot -1/2, -2. And I get the same shaped curve here in quadrant 3. So we have a new kind of a graph that's broken up by asymptotes. The y and x-axis in this case are both asymptotes. This kind of a graph, the whole thing, is called a hyperbola. It's a new kind of a graph. So a reciprocal function will give you the graph of a hyperbola. It has 2 asymptotes and 2 pieces, 2 curves. Okay, now for the log base 10 graph, I want us to go to our Inspire for a minute. So we're going to switch desktops here. And let's find that button. Log button is right here above 10 to the x. So to get to anything above, we're going to say Control 10 to the x. You notice it gives you a place to put the base, and for this problem I said base 10. And then over in the parentheses, we're going to use x. And when I push enter to graph it, I get a curve. Now again, I want some good points on it. So let's go Control T, get a table of values. And you can see again, when x is 0, y is undefined. There is another asymptote. When x is 1, y is 0. So we can plot that. Let me go back to our image. So when x is 1, y is 0. When we go back to our Inspire document, I get lots of fractions in there, and you'll understand more about this as we study logs more carefully. Again, the point of this chapter is to get used to some good graphs so that you can do transformations to some parents. And then when we study logs more carefully, you'll have already graphed them and be more comfortable with them. The only other really good point on a log graph base 10 for now is the point 10, 1. So we will go to our graph and plot the point 10, 1. Let's go to this and plot 10, 1. So really only 2 points are going to determine that curve for now and show that that y-axis is an asymptote. And that's the best we can do. So we now have our 7, let me zoom out, sorry, our 7 parent graphs. The first 4 are the most common. Those are the ones we're going to be messing with most in this class. These 3 are common throughout this year, and that's why I put it in this chapter. Again, for exposure, sneak preview, so that when we study exponents and logs and reciprocals more carefully, you will have already seen the graph and you'll already be more comfortable with the transformations because, of course, math is consistent. So for now, know the shapes, be able to get these last 3 out of your Inspire by making a table of values, and make sure that you get those first 4 really well. Okay, the last part of this lesson is really just recognizing shapes. Notice it says on the next page, name the parent function associated with each graph below. So all I want you to do is recognize the shape. You need to get really good at looking at a graph like number 1 and saying, oh, that parent is y equals x cubed. You want to get good at looking at a curve that's kind of a half of a parabola. Must be it's an inverse of a parabola, or a y equals the square root of x. Anytime you see a v, right side up or upside down, you want to say, oh yeah, that's the shape of absolute value. And of course, anytime you see a parabola, you want to say that's the shape of y equals x squared. Again, here we have another one that looks kind of like this, but it's not reflected. So its parent is y equals the square root of x. And this last guy looks very much like x cubed, except it's been flipped. So it must have a parent y equals x cubed. And that's really all we need you to know for now. We're going to use this, recognizing shapes of parents, to write equations of crazy stuff later on. But for now, I need you to know these 4 parents very, very well, be able to graph them without an Inspire, and be able to look at a picture and recognize the basic shape. And that is it for today. See you tomorrow.